Hi ladies, this is lesson 4.4, and in this lesson we're going to look at proving lines parallel. So already we have several theorems about angle relationships within parallel lines. We have the alternate interior angles theorem, the alternate exterior angles theorem, the corresponding angles theorem, the consecutive interior angles theorem, and then yesterday we looked at the perpendicular transversal theorem. So we're just going to make a list. We're going to brainstorm what is true about all of these theorems. So first, let's look at the alternate interior angles. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Let's look at our next angle relationship, and that's alternate exterior angles. So if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. The third angle relationship we looked at was corresponding angles. So if two parallel lines are cut by a transversal, then corresponding angles are congruent. And then the last one doesn't talk about congruence, but it does talk about parallel lines cut by a transversal. So the last one we're going to list is that if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. And remember, the converse of all of these is also true. The last theorem that we looked at yesterday is the perpendicular transversal theorem. And this theorem says that if a transversal is perpendicular to one of two parallel lines, it is perpendicular to the other. And then we also stated that the converse of this theorem is also true. So the converse is if a line is perpendicular to two other lines, then the two lines are parallel. So remember, when you list the converse, you flip the if and the then part. So the converse of all of these first statements that we gave, the converse of all of these statements is true. So I'm just going to read through or explain what the converse of each of these would be. So the conditional is that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Therefore, the converse would be if alternate interior angles are congruent, then the two lines cut by the transversal are parallel. If alternate exterior angles are congruent, then the two lines cut by the transversal are parallel, and so on. So remember, the converse is true, and it switches the if and the then part of the conditional statement. So we're going to use these converses to show whether or not lines are parallel. So we can show lines are parallel if, and we're going to use all of those converses that we just listed, if alternate interior angles are congruent, we can show lines are parallel if the converse of the alternate exterior angles theorem. So if alternate exterior angles are congruent, we can show lines are parallel if corresponding angles are congruent, we can show lines are parallel if we can show that consecutive interior angles are supplementary, And then lastly, using our most recent theorem, we can show lines are parallel if they are perpendicular to the same line. So if we can show that any of these 5 statements are true, then we can show that the lines are parallel. So let's look at this first example here. It says that in the figure below, name the relationship between angle ABC and BCD. So first I'm just going to highlight those 2 angles that we're talking about. We can see that they're both marked 40 degrees. So let's decide if the relationship is one of these 5 things that we just listed. The way that I'm going to do that, and I think it's easier to just mark your diagram up a little bit. So I'm just going to extend these 2 lines, A, B, and CD, and I'm also going to extend my transversal. Just because that's how I'm used to looking at diagrams, I'm used to looking at the transversal going all the way through the lines and not just stopping at the vertex of the angle. So now that I've extended all of my segments, I'm going to look at the relationship between ABC and BCD. I notice that they're both interior angles. They're both between AB and CD, and they're on opposite sides of the transversal, where the transversal is BC. So that tells me that these are alternate interior angles. So I know that these 2 are alternate interior angles. I also can see that they're congruent because they have the same angle measure. So now that I know they're alternate interior angles and they're congruent, this is my first bullet here, my first converse statement that we looked at when we made our list. And if we can show that alternate interior angles are congruent, then the lines are parallel. So the next question is it possible to say that AB is parallel to CD? And the answer is yes. AB is parallel to CD because of the converse of the alternate interior angles theorem. Okay, that says that if alternate interior angles are congruent, then the lines are parallel. Okay, let's look at this next example, and it says in the following figures, identify any parallel segments and explain your reasoning. So in this example, this first box, GY, YGR, and DRA, these 2 angles, are both 90 degrees. Okay, that means that GA is perpendicular to GY and it's perpendicular to RD. Since GA is perpendicular to GY and RD, GY and RD have to be parallel. And that's the converse of that perpendicular transversal theorem. Okay, let's look at the next example. And here we can see that BA and CD, we can see that they are not parallel, because if they were parallel, then consecutive interior angles would be supplementary. So BA is not parallel to CD because consecutive interior angles are not supplementary. But if you look at BA and FE, these would also be consecutive interior angles, looking at BA and FE, and they are supplementary. Okay, so because 102 plus 78 is 180 degrees, and the relationship is consecutive interior angles, we can say that BA is parallel to FE. And then the last question would be, is DC parallel to FE? And we can look at those angles, but we can see that DC is 90 degrees and FE is 78 degrees. And those two angles are corresponding angles, and they are not congruent. Therefore, DC is not parallel to FE. So the only relationship we have for parallel lines is that BA and FE are parallel. Okay, let's look at the next couple examples. So here we're going to have to do a little bit of digging. So we might have to use a couple different theorems. So the first thing that I'm going to look at is maybe all angles that would be, if lines are parallel, all angles that would be congruent to that 113 degrees. And if the lines are parallel, then this angle right here will be 113 degrees because it would be a corresponding angle. This would for sure be congruent no matter what because it's a vertical angle. So I'm just going to mark these. Vertical angles would be congruent. And then if P and Q are parallel, this angle right here would be congruent because it would be, again, a corresponding angle. And this angle right here would be congruent because another corresponding angle to this one up here. And then I'm going to mark their vertical angles. Okay, so if these lines are parallel, if both sets of lines are parallel, all of those blue marks will be 113 degrees. So let's just test one. This would be 113 degrees. Now, how can I test that? Well, I can use my linear pair theorem because I'm also given that 67-degree angle measure. And 67 plus 113 is a straight line. It is 180 degrees. So therefore, this angle, the one that I just marked 113 degrees, and its corresponding angle are congruent. Therefore, the lines are parallel. Now, I don't have to do every pair, every relationship. That's all I need. As long as it's true for one, it's true for all of them. Okay, now I'm going to look at a different set. I'm going to look to see whether R and S are parallel. So I'm going to erase what I have. And if R and S are parallel, I'm just going to pick this line, line P, as the transversal. Okay, so I already know that since P and Q are parallel, that this is 67 degrees because it's a corresponding angle to the 67-degree angle I'm given. And if R and S are parallel, then alternate exterior angles will be congruent. So here are my alternate exterior angles, 67 and 68. They are not congruent, therefore I know that R and S are not parallel. Okay, and then let's look at the last one. And there's a bunch of different angles here, so we're just going to take it, or a bunch of different lines here, and we're just going to take it one step at a time. So let's see, is KJ parallel to PQ? That's the first question. If they are, alternate interior angles will be congruent, and we can see that they are not congruent. So KJ and PQ are not parallel. So now let's look at KJ and ON. I'm just going to make my way down the line. So KJ and ON, are these parallel? Well, if they are parallel, then consecutive interior angles will be supplementary. I know that this angle right here is 109 because it's a vertical angle to the angle that I'm given. And my consecutive interior angles will be 109 and 74. Those do not add up to 180, therefore KJ is not parallel to ON. Okay, so I'm just going to make my way down the list, and I'm now going to look at LM and KJ. If these two lines are parallel, then alternate interior angles will be congruent. My alternate interior angles are 74 and 71 degrees, therefore they are not congruent, which means that KJ and LM are not parallel. So now that we know that KJ is not parallel to any of these lines, let's work our way down. So is PQ parallel to any of these? And again, we're going to use all of those same theorems, or the converses of those theorems that we just looked at. Okay, all the angle measures that are in here are true. So whether or not the lines are parallel, those angle measures that are in there stay the same. Okay, so first I'm going to look to see what, I'm going to erase my highlights. I'm going to look to see the relationship between this 71-degree angle and this angle right here. Those two angles are corresponding angles. Okay, so if I can show that these corresponding angles are congruent, then I can show that PQ is parallel to ON. Let's move this line up so we can see. And I'm going to use, first of all, I'm going to use my linear pair theorem, and I can then determine that this angle is 71 degrees because a linear pair is supplementary. So this angle right here is 71 degrees, and then it corresponds to the other 71-degree angle that's highlighted. So therefore, I can conclude that PQ is parallel to ON. Okay, let's look at the next relationship. I'm going to see, is PQ parallel to LM? So again, all the angle measures I have in there are true. And I could use a couple of methods. I'm going to use, again, the corresponding angles theorem. So this 71-degree angle formed by PQ and the transversal, and this 71-degree angle formed by LM and the transversal, those are congruent. Therefore, I can conclude that PQ is parallel to LM. Okay, and then my last pair of angles, I'm going to see if ON is parallel to LM. And for this one, I'm going to use my consecutive interior angles theorem, or the converse of the consecutive interior angles theorem. So I'm going to look at the 71-degree angle and the 109-degree angle because those are consecutive interior angles, and they are supplementary. So I can conclude that ON is parallel to LM because consecutive interior angles are supplementary. Okay, so here are the justifications for those three sets of parallel lines. We don't really have any information about KP and JQ, so we can't really determine whether or not those are parallel. And same with OL and NM. We don't really have any information about those, so we can't determine whether or not they're parallel at this point. Okay, in this next example, it asks us to find the value of x so that A is parallel to B. So if A and B are parallel, then I know that the transversal is also going to be perpendicular. We can see that it's perpendicular to A, but if A and B are parallel, then the transversal will also be perpendicular to B. And if there's one right angle formed by intersecting lines, then there are 4 right angles formed by intersecting lines. So I know that 7x minus 1 is going to equal 90. So I can set that equal to 90, and then I can just use algebra to solve for my variable. So 7x minus 1 equals 90. Therefore, adding 1 to both sides, I get 7x equals 91. And then I can divide both sides by 7, and 91 divided by 7 is 13. So x is equal to 13. I can only conclude that's true if these two lines are parallel. If I don't know A and B are parallel, then I have no clue what 7x minus 1 is equal to, but it says find the value of x so that A is parallel to B. Okay, so same with this next example. I'm just going to assume these are parallel because we're looking for the value. X has to be in order for them to be parallel. And again, it's sometimes a little bit easier to extend your lines and extend your transversal. So I just extended my lines A and B, and now I'm extending my transversal, just so that I can more easily see the relationships, because I like to look in between the set of lines. So I can see now that these two angles that are given in the expression 8x plus 6 and 14x minus 2, these are consecutive interior angles. And in parallel lines, so if A and B are parallel, consecutive interior angles have to be supplementary. Okay, so therefore I can write an equation that says 8x plus 6 plus 14x minus 2 is equal to 180. I'm going to start solving for x by combining like terms. So I get 22x plus 4 equals 180. And I'm going to subtract 4 from both sides to isolate my variable. So 22x equals 176. And then lastly, I'm going to divide both sides by 22 to solve for x. 176 divided by 22 is 8. So if A and B are parallel, then x is equal to 8. If x equals something other than 8, the two lines are not parallel. And then let's look at this last example. In example 4, it says find the value of x so that AC is parallel to DE. So here we're looking for AC, and again, I'm going to extend my lines, and AC is parallel to DE. So I'm just going to extend these. So we're looking for the value of x. So we need to look at an angle or a transversal between AC and DE that forms angle x. Okay, so AE is going to be the transversal we're looking at. And in parallel lines, which would be AC and DE, so within parallel lines, alternate interior angles are congruent. So I have this angle, 55 degrees right here. Angle AED is 55. Therefore, angle EAC has to also be 55 degrees. Therefore, x equals 55. Okay, then the second question is, if AC is parallel to DE, can you determine if AB is parallel to CD? Okay, so let's just write in some things that we know. So assuming that AC and DE are parallel, we know that this angle right here is 55. This angle right here is given. We also know that this line AC is going to be 180 degrees, so we can find this angle right here. So remember, linear straight angle is 180 degrees. So 55 plus 30 plus this green angle right here has to equal 180 degrees. And we could find a whole bunch of other things. We don't really need to do all of that. But just for the sake of problem solving, I'm just going to put it in there. Okay, so this angle that I highlighted green is 95 degrees. And I know that because I know that X, let's not use green highlighter. I know that because this angle right here adds up to 85 degrees. Okay, so my X plus 30 is 85 degrees. Now I'm looking to see if AB and CD are parallel. So I'm going to go ahead and highlight those angles. And we'll use blue this time. So are AB and CD parallel? I'm going to use AC as the transversal. And if I look at this pair of angles, one is already given and the other I just found. So this 85 degree angle, which measures right here, this 55 plus 30, and this 85 degree angle, those are corresponding angles. Okay, so because corresponding angles are congruent, then yes, I can determine that AB is parallel to CD. So because measure of angle CAB equals 85 degrees, and the given 85 degree angle and CAB are corresponding angles, and they're congruent, AB has to be parallel to CD. And that's the converse of the corresponding angles theorem. So please jot down any notes or questions that you have, and we can go over them next time I see you in class. Thank you.